Hello everyone, welcome to the Material Science course, Make 300. This is Dr. Muhammad Chat. I'll be discussed over this video chapter 2 of this course, which is the atomic structure and the atomic bonding. This chapter actually will be covered over 3 videos. This is the first one. In this video and the next videos or through the chapter, we are going to discuss the structure of the atom. In addition, we're gonna fix some keywords, what is the difference between atom, element, compound, and mixture, these different forms of the material or a substance. Then a great part of this course, this chapter will be devoted for the atomic structure or the atomic bonding, or in other words, the different forces that would exist at the atomic scale. I'm going to explain this part of the different forces in a way which is a little bit different than what is represented in the textbook, or more comprehensive than what it is represented in the textbook. But actually it is highly important to understand these different types of forces and how they would be related to the different types of forces that we already discussed or covered over the chapter 1. So we discussed the metallic forces, metals, ceramics, polymers, based on their chemical composition. So how these forces would impact or related to the material type and the properties of the material, which is the main concern of this course actually, is to understand how the material structure, how these atomic bonding and atomic forces would influence the material properties or this relation. This is what we are interested in through this material science course. So all of these different things will be covered through this chapter. Again, this will be covered over 3 videos. This is the video 1 of this chapter. So these are the different learning outcomes that we are going to fix through this chapter or these 2 videos, which is, first one is acknowledging the atomic structure or the structure of an atom, how the atom is composed. In addition, knowing the definition of the atomic mass, what does it mean atomic mass, and what is the difference between the atomic mass and atomic weight, and try to understand how we could calculate these 2 quantities, physical quantities for a specific atom or an element. Also acknowledging and distinguishing between the different types of intramolecular forces. There are some types of the forces that we are calling them as intra. So there is a letter here, and intermolecular forces. So these are 2 different types of forces or group of forces. So it is highly important, and this is one of the main objectives of this course, is just to know these different types and the difference between the intramolecular forces and the intermolecular forces. In the meanwhile, identify the force and energy type depending on the material and molecule type. For example, if you do have 2 nonpolar molecules forming an element, so what type of forces that would be generated between, or energy that would be generated between these 2 nonpolar molecules, or one polar and the other one is nonpolar. So it means that these different types of forces that would be generated depending on the material type or the molecule type, this is also going to be discussed. Also, I'm just going to show you how we could calculate the van der Waals energy and forces that would be generated between different molecules. In the meanwhile, we're going to calculate the total intermolecular pair potential and forces that would be generated between different molecules. So these are the different objectives or learning outcome that we're going to try to fix through these 2 videos over chapter 2. Make sense? So starting with the first objective, which is what is the atomic structure or the structure of atom. Just to not be confused, here we are talking about the structure of the atom itself. What is the composition of an atom? So initially, we're just gonna try to fix some fundamental concepts, like we are going to distinguish between an atom, an element, and compound, mixture. So you should acknowledge the difference between these different keywords, or the difference between an atom and element. So starting with the atom is the smallest bits of ordinary matter. Matter is anything that exists. We mentioned before a material is a touchable thing, that anything that you could touch, this is a material. It should be made of a certain material, which could be named as matter. Matter, it means that something that has concern, something that we should care about or we should consider. It is considerable thing. So it means that matter is something that exists or material. So the smallest bit, the smallest thing within any material, it should be the atom. Despite that, the atom itself, it is composed of nucleus, it's composed of protons, neutrons, in addition to the electrons. But in terms of material science, our smallest unit, our smallest thing that we could consider for any material is the atom itself. So our reference is the atom, and then we can build up on these atoms. So we could say, for example, the material, it is colony of atoms. It means that you're going to have one atom, another atom, and another atom, mix it to form together a specific material or a specific ordinary matter. So the smallest bit of an ordinary matter is going to be the atom. This is what does it mean, the atom. This is the smallest thing. Each atom consists of a nucleus, which is going to be the core of this atom, and this is what consumes the most of the mass and the shape of the atom itself, which is encircled or surrounded by moving electrons. So the shape, the composition of any atom, and I'm pretty sure that you have an idea about these things from the physics class, that the atom it consists of nucleus, and there are some electrons who should be rotating around in different orbits around this nucleus, which located at the center of the atom. So this is like the ideal form of an atomic structure or the structure of an atom. Like these are the electrons, which are rotating in different orbits about the center or the core, which is going to be the nucleus of this atom. The nucleus of an atom is composed of protons and neutrons. The protons, they carry positive charges. They do have a positive charge of 1.6 times 10 to the power negative 19 coulombs. And the charge of the electron, which are rotating around the nucleus, they do have a negative charge of the same value as the proton, which is 1.6 times 10 to the negative 19 coulombs. But the neutrons inside the nucleus, so we said that the nucleus, it consists or it is composed of protons and neutrons. So all the protons and neutrons are located inside the nucleus. Here we are talking about the ordinary material, and these neutrons, they are electrically neutral. They do have zero charge. It means that they are neutral. And while the protons, again, they are positive charged, but the electrons are negative charged of the same charge, which is 1.6 times to the negative 19 coulombs. Make sense? So this is the conventional structure. And again, I'm pretty sure that you already have an idea about these things from the physics class. And again, the atom, this is the smallest bit. This is the smallest unit of any material. Like simply any material that we are experiencing in our life, simply we can break it down into an atom, into atomic structure, or into some atoms that form this entire material. So if we looked inside one single atom, we gotta find that this atom is composed of nucleus surrounded by some electrons, and these electrons, they are carrying negative charge, while the nucleus, it has a positive charge. Why the nucleus has a positive charge? Because of the protons that they do carry positive charges. So that's why there is kind of interaction, there is kind of polarity. This is known as polarity, and there should be some electrostatic force that, or electrical force, that is going to generate between the negative charge of the electron and the positive charge of the proton. But while the neutrons, they already by nature, they already electrically neutral. So this is the structure of an atom. Now let us move. What does it mean, an element? We have mentioned this once before over the previous chapter or videos. We mentioned that an element is a material substance. So it is just a material. So the element itself, it is a material substance, or a colony, that is a colony of atoms, group of atoms. So many atoms form one element, but the key condition that all of these atoms should be of the same type. So we're gonna say that an element is a material substance that is made entirely, all the element, it should be made from one type of atom, one specific type of atom. So what does it mean? It means that you're gonna have like oxygen atom, and you're gonna repeat this atom a million times to form an oxygen element. So what distinguishes one element from the other one is the atom type itself. Make sense? And this is also what we discussed once before. So simply, we could say that the element, it is a colony of atom. Like you're gonna form one atom next to the other one to form one entire element. And the key condition again, that these atoms should be made of the same type. Atoms form an element have the same number of protons. This is the key condition. We said that the nucleus, it is composed of set of protons and neutrons, and these protons and neutrons, each one has specific number. In some of the cases, we may have the number of the protons exactly the same as the number of neutrons, or they would be different. But anyway, we do have some positive charges, which are the protons with a certain number of protons, and we do have a certain number of neutrons that form the nucleus of an atom, of a specific atom. So the key condition is, another key condition is that we mentioned that the element, it should be made of one type of atom. So the question is, what distinguishes one atom from another atom? When we look to the structure of the atom, we do have three main things that form this structure of an atom: electrons, protons, and neutrons. So if you do have two elements, and this is a key thing that you should understand, if you do have two elements and if you do have two atoms and both atoms, they do have the same number of protons, this definitely means that these two atoms are of the same type, exactly the same atom. So again, if you do have two atoms, one atom and another atom, and you are not pretty sure of both are of the same type or two different types, the same atom or two different atoms. This depends on the number of protons of the two. If the two atoms, they do have the same number of protons, this means that they are of the same type, and if they join together, they're gonna form an element. So atoms that form an element, they should have the same number of protons, but they may have different numbers of neutrons. So the number of neutrons would be different from one atom to the other atom inside the element. But the number of neutrons usually varies from one atom to another inside one single element. This gives different versions of atoms. Each one of these versions is known as isotope. So this is another keyword here. What is the isotope? Isotope, it is a version. It is a form of the same atom. But if you do have two atoms of the same type, this means, since they are of the same type, this means that they should have the same number of protons. But if this atom has a number of neutrons that is different than this one, so we're gonna say that these two atoms are of the same type, but they are two different isotopes. We cannot say that they are two different atoms. They are still the same two atoms, but two different isotopes. So what is the isotope? The isotope depends, it is a version, it is a form of the atom that depends on the number of the neutrons. What makes this isotope is different than this one, that both, they should have the same number of protons, but two different numbers of the neutrons. Make sense? So the key condition that to have two atoms of the same type, that they should have the same number of protons, but if they do have different numbers of neutrons, it means that they are two different isotopes. So what is the isotope? What is the isotope? It is a version of the atom, of the atom that depends on the number of the neutrons, such that two isotopes having two different number of neutrons, but having the same number of protons. They should have the same number of protons to be isotopes of the same atomic type. Make sense? And we mentioned that the element, it is composed of the same atomic type. It means that all the atoms that form one single element, they should have the same number of protons, but that is fine if they do have different numbers of neutrons. As you change the number of the neutron, you're already changing the isotope type. So we do have one isotope, another isotope, and so on to form an element. So the question is it fine if we could form an element of two different or multiple different isotopes? Yes. Is it fine if we can form an element, or is it possible to form an element of different atomic types? No. The element, it should be made of the same atomic type. All these atoms, what should be the common between them? The number of protons should be the same. But the element, it could be formed of different isotopes. What is the common between all of these isotopes? They should have the same number of protons, but they may have different numbers of neutrons. Make sense? So all isotopes of a particular element, we're still talking about the element, have the same number of protons. This is a key condition, but they can have different numbers of neutrons. If you change, generally speaking, if you change the number of protons, you're already changing the atom. You're already changing the element. You're going to end up with a different element. If you change all the number of protons within the atoms that form an element, you're going to end up with a different element, a new element. Make sense? So, if you change the number of protons an atom has, you change the type of the element itself, or the type of the atom, which will definitely change the type of the element. If you change the number of neutrons, you are not changing the type of the atom. The type of the atom is still the same, but you are changing, you are making an isotope of that element or isotope of this atom. Like you are forming a new isotope. New isotope with a different number of neutrons. So generally speaking, elements are made of different isotopes of the same atomic type. That they should have the same type of atom, but they may have different isotopes. What distinguishes one isotope from the other one is the number of neutrons will be different from one isotope to the other one. Make sense? So this is the difference between atoms, or the atom, and the element. The element, there is a composition of set of atoms of the same type. What about the compound? The compound, there is a chemical compound, it is a substance, also it is a material. So all of these are different materials. We're gonna deal with them like materials. So the compound itself is a substance, or it is a material that is made of two or more different elements. This is the condition, that the compound, it consists of molecules, and the molecule, it is the chemical composition of two different elements. So the key condition is that you should have two different elements in many of the cases to end up with a chemical compound. So it is made of two or more different elements, and remember that every element, it consists of the same type of atoms. So you're going to have one element that is made of a specific atom, and another element that is made of a different atom, and you're going to chemically combine or join them together to end up with a compound or a molecule. This molecule, when it is repeated, is going to give you a compound. So the compound, it is a composition of molecules, and the molecule, it is one element of one type, atomic type, and it is a chemical interaction between, or reaction between, one element of one atomic type with another element of another atomic type to form a molecule. If you repeated this molecule many times, you're going to end up with a chemical compound. So it is a substance that is made of two or more different elements that have been chemically joined. So there should be a chemical reaction that should exist there. Examples of compounds are water, like you're gonna have one element which is oxygen and two elements of hydrogen to end up with water, like salt, which is sodium chloride, which is NaCl. So this is one element, this is another element that form a molecule. So this is one molecule, and this is another molecule. If you repeat this molecule million times, you're gonna end up with water, or you're gonna end up with salt, which is just a substance or a material. Make sense? So this is, what does it mean, compound, and what distinguishes compound from another element? So the question is, that is fine. Is it fine if the atom that form a compound, they do have different protons, number of protons? Yes. Why? Because the compound, by definition, it should be made of different elements. It means that this element, it should have a certain, all the atoms that form that element should have the same number of protons, but the number of protons of the atoms of the other element should be different. So the compound, by definition, it should be made of atoms of different protons. Make sense? So this is what distinguishes the compound from element from the atom. Another thing that you should acknowledge here is the mixture. What is a material mixture? Mixture is a substance also. It is type of material that is made by combining two or more different materials or two or more different elements, kind of, in such a way that there is no chemical reaction occurs. This is the condition, that there is no chemical reaction between these different elements or different material. A pretty good example of this case is the composite material. This is how we make the composite material as we defined composite over the previous chapter. We said that it is a material mixture. It is not a material compound. If you remember, in our definition of a material, of ceramic material and composite, we said that ceramics are a material compound. It means that there should be chemical reaction between the different elements that form a ceramic material. But the composite material, it is a material mixture. Mixture, it means that it is combination, that you combine metal with ceramic, two different elements or two different materials, but the condition is that there is no chemical interaction is going to take place between these two different materials. So this is what distinguishes a mixture from a compound. Mixture, in many of the cases, this is the thing that we can do. You can mix two different materials together without any chemical reaction. So this is gonna give us like a mixture, right? So these four things you should, or five things that you should understand what is the atom, and you should understand that the element is composed of the same atomic type, but it would be of different isotope, and you should understand what does it mean isotope. Also, you should distinguish the element from compound from a mixture. So these different things, you should understand them well. Now let us move to another keyword here, which is atomic number and atomic mass and the atomic weight. So what is the difference between these three keywords? So the atomic number, which we're going to refer as Z as usual, is the number of protons in the nucleus. So the question is, what distinguishes one atom type from another atom type is the number of protons. So the number of protons is the atomic number. So the question is, can we consider the atomic number as something that distinguishes one atom from another atom, or one atom type from the other atom type? Yes. Why? Because the atomic number is the number of protons of the inside the nucleus. And this number of protons, it is a property that distinguishes one atom from another atom. So each atom number, its atomic number identifies a specific element. Why? Because the number, what distinguishes one atom from another atom is the number of protons. All the atom types, all atoms of the same type, they should have the same number of protons. So by definition, atomic number, it is a property that identifies a specific element. And we said that the element, it should be made of the same type of atoms. It means that all the atoms should have the same number of protons, or in other words, all atoms that form a specific element, they should have the same atomic number. So simply, the atomic number, it is the number of atoms, number of protons of the nucleus of an atom or an element, that of the atom that form an element. It means that the atomic number, it is a property of a specific element. The atomic number ranges between 1 for hydrogen to 92 for the uranium, which is this what distinguish and this is the range that based on which we're already building the periodic table of the different elements as we discussed over the previous chapter. Now let us move to the atomic mass. What is the atomic mass, which we're gonna give it a number, a symbol as, or a letter E? Is the mass, it is the mass of an atom. Like if you have an atom and for some reason you would like to calculate the mass of that atom, or to come up or measure the mass of this atom, we can do using and define this mass by the atomic mass, or something that we can even define molecular mass, which is in case that you don't have a molecule, but in case that you don't have an atom, so we're gonna have the atomic mass. What is this atomic mass exactly? It is the sum of the masses of protons and the masses of neutrons within the nucleus of an atom or isotope. Remember that what is the isotope? It is a version of the same atomic type, but of different neutrons. So the number of protons for this atomic type will be fixed. Certain value, constant value, it won't gonna change unless you change the atomic type. But the number of neutrons would be different from one atom to the other atom, or from one isotope to another isotope. So if you are interested in calculating the atomic mass of an isotope, you should find the mass of all the protons that form this atom or this isotope, and also you're gonna calculate the mass of all the neutrons that form this isotope. Sum all of these masses together, you're gonna end up with the atomic mass. Make sense? This is simply how we could calculate the atomic mass. Away of this definition, if I ask you, and this is what we discuss here, what are the things that would be exist inside the atom? We said that the atom generally it consists of three main things: electrons, neutrons, protons, right? And there should be a specific mass for the electron, a specific mass for the proton, for the neutron. So if I ask you to calculate the mass of this entire atom, what you're gonna do, simply speaking, just simple math. So what you're gonna do, you're just gonna calculate the mass of all the electrons, then you're gonna calculate all the masses of the neutrons, all the masses of the protons, and sum all of these masses together, you're gonna end up with the entire mass or the total mass of the entire atom, right? So in our definition here, we said that the atomic mass, which it should be the mass of an atom, it is the sum of masses of the protons and the masses of the neutrons. How about the electrons? The electrons, they do have masses, yes, but its total mass, the total mass of the electrons in comparison to the mass of the protons or the neutrons, it is very negligible. So that's why usually when we calculate the atomic mass of an atom, we don't consider the mass of the electrons that would exist inside this atom. Why? Because their masses in comparison to the mass of the protons and the neutrons is very negligible. So that's fine. That's fine. This is one approximation. This is one assumption that we are neglecting the effect, or we are neglecting the mass of the electron. Why? Because their masses is very negligible in comparison to the mass of the protons or the neutrons. So that's fine to say that the atomic mass is the sum of masses of the protons and neutrons that form the nucleus of an atom. Very simple, or isotope. Make sense? Another approximation is, when we calculated the mass of the proton or the mass of the neutrons, we found that the total mass of the protons and the total mass of the neutrons that form a nucleus of many of the elements, it is almost equal to the number of protons and the number of neutrons that form this nucleus of this atom. Again, since we are talking about a mass, the unit of any mass should be grams, kilograms, in that form, right? So to calculate the mass of this atom, we should calculate the mass of the protons, the mass of the neutrons. When we calculated the mass of all the protons that form a certain nucleus, we found that it is approximately equal to the number of protons. So simply to come up with the mass of the protons, count how many protons, this is the mass directly. Although it is not accurate calculate or exact calculation of the mass, but when we did calculate it, the mass of the protons of many of elements, we found that this mass almost equal to the number of protons. And we defined here the number of protons at the atomic number, So this Z, which stands for the atomic number or the number of protons, here we are approximating this number at the mass of the protons. Why? Because they are very close. There is no big difference between, or the difference between the mass of protons and their numbers is very negligible. The same thing applies for the neutrons. When we calculated the mass of the neutrons, we found that their mass almost equals their number, their count. So if we simply to calculate or to quickly calculate the atomic mass of any element, of any atom, your objective is just to count how many protons, count how many neutrons. Sum these two counts together, you're gonna end up with the atomic mass. So despite we already summing numbers, not masses, we almost gonna get the same atomic mass as if we did calculate exactly the mass of the protons and the mass of the neutrons and we sum them together. So approximately we can say that the atomic mass, it is equal to the number of protons plus the number of neutrons that form a nucleus of an atom or isotope. But the accurate definition of the atomic mass is that it is the sum of masses of the protons and neutrons, and since the masses of protons and neutrons are almost equal to their numbers, so that is fine to sum their numbers. So that's why A, which is the atomic mass, it can be approximately equals the number of protons, which is the atomic number, plus N, which stands for the number of neutrons. So N stands for the number of the neutrons. Make sense? This is gonna give us the atomic mass, and usually it is given or the conventional unit of the atomic mass, it is atomic mass unit. It is AMU, which stands for atomic mass unit, which is Dalton. This unit actually, it is 1 atomic mass unit equals 1/12 the mass of an atom of carbon. 12, it means that this is how they define this thing as like a universal unit that would be used for as a unit for the atomic mass. Like for example, for the mass of any substance, we usually measure the mass using grams or kilograms or whatever. For the atoms, we used to define the atomic mass by the AMU, which stands for atomic mass unit, or Dalton, which is equal to 1/12 the mass of an atom of the carbon, and this carbon, it was used like a reference in that case. Make sense? The mass of the electron, it is usually 0.0005 AMU. So that's why we didn't count for how many electrons, or we didn't consider the mass of the electrons when we did calculated the atomic mass. Why? Because the mass of the electron, it is very negligible in comparison to the mass of the protons or the neutrons inside one single atom. Make sense? If you decided to convert from atomic mass unit to the grams, 1 atomic mass unit equal to 1.66 times 10 to the power negative 24 grams. So this is how we could convert. Like for example, if you do have an isotope with atomic mass unit of 12 or of 20, so simply you're gonna calculate, multiply this number times this value, which is 1.66 times 10 to the power negative 24. You're gonna convert into grams, so you could end up with the atomic mass of this isotope or this atom. Make sense? So this is simply what distinguishes the atomic number from the atomic mass, and simply how we could, or how can, or usually we do calculate the atomic mass of an isotope or an element. Make sense? Another keyword here is the atomic weight. What is the atomic weight? It is the weighted average of the atomic masses of all the isotopes forming an element or compound. Remember that we said that the compound, it is a substance that is consists of or made of 2 or more different elements, and every element, it consists of different isotopes. But the isotope, the common between them, the isotopes within a certain element, the common between them that they should have the same number of protons. But that is fine if they do have different number of neutrons. Make sense? So if you do have a compound, or you do have an element, and if I ask you to calculate the atomic weight, so this is the atomic mass, right, of one single isotope or one single atom. But if we consider an element, for example, and this element is made of one isotope, isotope 1, and it is made of another isotope. Remember that this is like one atom with different number of neutrons, and this is another atom of different number of neutrons, and there is a third isotope. Like assume that this element is just made of 3 isotopes. Make sense? Assume that. So if I ask you to calculate the atomic mass which is A for this isotope, what you're gonna do, you're just gonna sum the number of protons, which should be the same number of protons of all the isotopes, plus the number of neutrons that is specified for this isotope. What distinguishes this isotope from this one, that they do have different number of neutrons. So since the number of neutrons are different from one isotope to the other, this means that the atomic mass for this isotope is different than this one, is different than this one. So we do have RE1, which is the atomic mass of this isotope, is not equal to the atomic mass of the second isotope, is not equal to the atomic mass of the third isotope. Make sense? So the question is, what should be the atomic weight or the atomic mass of this element? This is the entire element. How could I define then the atomic weight of an element? But the atomic mass, it is the mass or the weight of one single isotope, one single atom. That's it. But how about if we are interested in finding the weight of the entire atom element that is composed of different isotopes? Every isotope, it has its own atomic mass or atomic weight. Make sense? It has its own atomic mass. So what should be the atomic mass or the atomic weight of the entire element? Which one that we choose? None of them. We have to calculate the average. That is fine to consider the average of all of these different atomic masses. So simply, the atomic weight of an element or compound, it is the weighted average of the atomic masses of the isotopes forming an element. If all of this element, it is made of one type of isotope, different atoms, but of the same isotope, all of them, all of these atoms, they do have the same number of protons, the same number of neutrons, it means that the atomic weight of this element will exactly the same as the atomic mass of these isotopes. But this is under only one condition, that this element or compound is made of one isotope. But if it is made of multiple isotopes, and this is the conventional thing, usually elements that we are using in different engineering application, compounds, they are made of different isotopes. So to come up with the atomic weight of this element or compound, you should calculate the atomic mass of all the isotopes and calculate their average. This is going to give us the atomic weight. So the atomic weight, simply, it is the weighted average of the atomic masses of isotopes that form an element or compound. For an element, usually it is called atomic weight. For compound, we give it a name as molecular weight, because the compound, it is usually made of molecules, but the element, it is usually made of atoms. And remember that the molecule itself, it is already made of atoms, but the molecule, it cannot be counted as an element. So again, the element, it is made of atoms, but the condition is that this element, all of its atoms should be made of the same type. Like all the atoms of this element should be of the same type. But the molecule also is made of atoms, but these atoms are different types. So that's why it is a molecule. You got my point? And if you repeated this molecule multiple times, you're going to end up with a chemical compound, right? So for a compound, usually we give a name to we usually use molecular weight instead of the atomic weight. But for element, we are using atomic weight. But that is fine even if you use for compound or element atomic weight. For both of them, that is fine to do so as well. Make sense? But generally speaking, what is the atomic weight? It is the weighted average of the different atomic masses of the isotope that form this element or the compound. The atomic weight unit, it is usually AMU, which is atomic mass unit, divided by atom. Why? Because you are taking the average. So you are taking the average, you are counting how many of atoms or molecules that exist, and you divide it by their count, kind of. So you're gonna end up, so in the denominator, there should be here an atom. Like this is the atomic mass unit per one single atom or isotope that form this element. In case that would have a compound and we are interested in the molecular weight, so we give it, the unit is gonna be atomic mass unit per molecule. So we are finding the mass of that molecule, of one single molecule of this compound, or the mass of one single atom or isotope of this element. Usually the one atomic mass per unit, atomic mass unit per atom or molecule equals to 1 gram per mole. The mole refers to the 1 mole of the material, and the 1 mole of material or the substance, it equals to the 6.023 times 10 to the power 23, which is commonly known as Avogadro's number. of atoms or molecules. So what does it mean? If you do have an element, and this element is just 1 mole, if you do have 1 mole of this element, so the question is how many atoms, or in other words, how many isotopes that form this element? If you do have 1 mole of element, how many atoms exist or form this 1 mole of element? Or in other words, how many atoms are exist in 1 mole of element? So the count of the atoms, in case that we are talking about elements, or the count of molecules, in case that we are talking about a compound, equals to the Avogadro's number in 1 mole. So it is a constant value, which is known as the Avogadro's number. It is 6.023 times to 10 to the power 23. This is gonna give us how many atoms found for 1 or form 1 mole of a specific element, how many atoms that form 1 mole of how many molecules that form 1 mole of a specific compound. It should be the Avogadro's number. So simply we can define the atomic weight by 1 atomic mass per atom, or 1 gram per mole, to end up with this as a mass for the as a unit for the atomic weight of an element or compound. Make sense? So what we discussed so far, we defined what does it mean atom, what distinguish atom from element, from compound, from mixture. Then we discussed the difference between atomic number, atomic mass, and the atomic weight, and we discussed in detail how we could calculate these 3 quantities for different atoms, elements, or compounds. Make sense? Next, what we're gonna do are going to discuss the forces at atomic scales. Forces at atomic scale are so many. There are lots of atomic forces and different forms of these forces, but we can group them into 2 main groups. There are some forces which are located inside the boundary of an atom, and these forces, it is not just one force, it is like a group of forces or a set of forces that located inside, all of them located inside the boundary of an atom. They do have 0 effect outside the atom. Their effect also is bounded inside the atom itself. This set of atoms which are located inside the atom, this set of forces, that located inside the atom, they are responsible for forming the atom as a single unit, as a single object. In addition to these forces that located inside the atom, there are some other forces who are located outside, or their effect works outside the atom. And these other forces which are located outside the boundary of the atom are responsible for the interaction between one atom with the other atom to form an element or compound. So these different forms and types of forces, this is what we are going to discuss in this part in the rest of the chapter. But let us discuss an important point here. Like most of the macroscopic properties, we said that the material, it has different levels of structure over the previous videos, right? Or different level of scales. We do have the macroscopic scale. This is how we see the material at the larger properties of the material. But there are some properties of the material which are conjugate to the material microstructure. There are some other properties which are related to the material nanostructure, and there are others who are related to the atomic structure. So many of the macroscopic properties of the material, they are dependent basically on the material's atomic structure and the forces occur at the atomic scale. Or these properties depend on how the atom that form this material. We said that in the material it is a composition, we can break it down into just one atom, right? So multiple atoms. So what is the structure of all of these atoms that form this material? In addition, what type of forces that generate at this atomic scale? All the properties of the material are dependent on these forces, dependent on the atomic structure or the structure of the atom. For example, a very pretty example that I'm pretty sure that you have an idea about this. If I ask you why solids are stronger than liquids or gas, simply you're gonna say that because of the molecules or the atoms that form the solid material are strongly held together, or are strongly bonded together through a stronger force than the force of bonding the molecules or the atoms of the liquid or the gas. So that's why solids are stronger than liquids or gases. So it is the same. So it is related to the bonding, type of bonding. It is related to the type of force that exists at the atomic scale between the molecules or the atoms. So that's why these type of forces are very important to understand them. Why? Because remember that the main objective of this course is to understand the relation between the material structure and the properties of the material. So it is highly important to know how these forces would impact the microscopic or the different properties of material, and this is why we are discussing these atomic forces. So for example, solids are stronger than liquids or gases. Why? Because of the stronger interaction between atoms that form the solid material in comparison to the interaction or the interaction forces that would exist between the molecules or atoms of liquids or gases. So as I mentioned, there are many different forms and types of interaction that can be observed inside. Some of them are outside the boundaries of atoms or molecules. Atoms in case that we are talking about an element, molecule in case that we are talking about a compound, right? So this means that there are some interaction that exists between the atom that form one molecule. There are some interactions outside the molecule between the molecule themselves, right, that form a compound. First, we're gonna discuss the forces that would be located inside the atom. This is the first thing. Then we're gonna discuss the forces that would be located outside the atom. Inside the atom, there are four basic types of forces. These forces are electromagnetic force, gravitational force or gravity force, strong force, and weak force. They are called that name, strong force, weak force. So there are four forces that located inside the atom, and these forces are responsible for forming an atom. So the electromagnetic force, this is one of the four that we could understand inside the atom. For example, it is the attraction, this electromagnetic, it is the attraction force that generates between the nucleus of an atom. We said that the nucleus, it has a positive charge. Why it has a positive charge? Because the nucleus, it consists of protons and neutrons. The neutrons, they do have zero charge, but the protons, they do have a positive charge. So entirely the nucleus of an atom, a regular atom, it is of a positive charge. But the electrons that rotating around in different orbits around this nucleus, they are carrying negative charges, right? So definitely from the physics laws, if you have a positive charge and negative charge, these two charges will be attracted together. And this is what makes electrons rotating in fixed and definite orbits around the nucleus. Because of what? Because of some forces that generate between the negative charge and the positive charge of the nucleus. This force is known as the electromagnetic force. So simply it is attraction force. They're gonna be attracted together because of the difference in the polarity. Different in polarity, it means that it has a positive and negative. So this is a polar interaction. This generates some electromagnetic forces, which one of the forces that would be generated inside the atom, generated specifically between the nucleus of a positive charge and the electrons of a negative charge, around it, keeping them traveling. So this force is, what is the function or the objective of this force? Is just to keep electrons traveling in their continuous and definite orbits around the nucleus. So this is one of the forces that would be exist inside the atom. Another force is the strong force, is known as the strong force. This force is the force that opposes the electromagnetic force of repulsion between protons. Protons, we said that the nucleus, it consists of protons and there are neutrons. The neutrons, there is no big deal regarding the neutrons. They are neutral, right? So in terms of charges, they do have zero charges. But the big deal is with the protons. The protons, they are carrying positive charges and they are merged and joined together to form the nucleus, side by side with the neutrons, right? So the question is, all of these protons, every single proton, it carries a positive charge. And from the physics, we knew that in case that we do have two objects, no matter what these two objects are, if you do have any two objects of the same charge, there should be some repulsion force generated between. They're gonna push each other apart. Like this one is gonna push the other one in the other direction. So they won't gonna be attracted together, and instead they gonna be repulsive with respect to each other. But if we did so, it means that these protons cannot be joined together to form a single unit. Instead, they're gonna be dispersed. They're gonna be moved apart. Make sense? But this is not the case. Inside the nucleus, these protons are held together. So this means that there should be another force that works opposite or against the electromagnetic force that would like to push these protons apart. There is another force that collect them back again. And this force, it should be stronger than this repulsive force due to the charges between the proton to keep them like a single unit. So again, protons, all of them need to have positive charges. So there should be some repulsive forces between them that make them apart and make them like apart and disperse it to not form a single plot or object or single unit inside the nucleus. But this is not the case. These protons are forming one single unit and strongly hold together. So this means that there should be another force that overcomes the effect of the repulsive force due to the charges of these protons that would be used to hold them together as a single unit. This force is the strong force. So you should understand something here, that the strong force, it is not the repulsive force between the protons. It is another force that would collect the proton together as a single unit. So that's why it is a strong force. We usually call it as a strong force because it is stronger than this repulsive force between the protons. So it should be a very high force that merge them and bond these protons together as a single unit. So strong force is the force that opposes the electromagnetic force of repulsion between protons. Strong force keep, its function is to keep the protons together to form the nucleus. But the electromagnetic force, its function is to keep the electron traveling in a continuous and definite path or orbit around the nucleus. But the strong force is the force that opposes the electromagnetic force that generated between the protons as repulsive force due to their positive charges. And this force, it is responsible for keeping the proton together to form the nucleus as a single unit to form the nucleus inside the atom. Make sense? In addition to the strong force of the electromagnetic force, we do have another force which is known as the weak force. But this is a special force that generates between special atoms. These atoms should be of unstable nuclei. Like if you do have an atom or subatom, like it is a part of atom, it is not incomplete atom. Okay, so this atom will be qualified as unstable atom or subatomic particle or some subatom. It is like a part of atom. It is unstable of unstable nucleus. Unstable nucleus, it means that the atomic nucleus loses energy by emitting radiation. This process is commonly known as radioactive decay of an atom. So if the atom emits some radiation known as the process of radioactive decay of that atom, it means that this atom, it is a subatom or an atom with unstable nucleus. In this process, so in the radioactive decay, the neutron, one of the neutron or some of the neutrons inside the nucleus is broken down into rechanges into proton and electron of the same charges. Remember that the neutron should be of neutral charge. The positive equal to the negative or zero charge, kind of. So if you have a neutron, which is neutral, and this one it changed into positive and negative charge of the same charge, or proton and electron of the same charge, this process is known as radioactive decay. And in order to do this process, the atom will emit some radiation. So that's why we got the name radioactive decay of the atom. And in order to do this process, you require some special forces that would be used to connect these unstable atoms together. This force is known as the weak force, or sometimes we give it a name as weak nuclear force. This is the force that is responsible for the radioactive decaying of atoms. This is the weak force. So the weak force are the forces, or the weak force is the force of interaction between atoms with unstable nuclei, What makes the nucleus of an atom unstable is that when this atom emits radiation, this process is known as the radioactive decay of an atom. Within this process, one neutron or more within the nucleus of the atom will be changing into proton and electron. And in order to perform this process, this requires some special forces that would connect these subatoms together, is known as the weak force. Make sense? The fourth type of force is the gravity force, and this is the weakest of them all. This is the weakest force of the four forces that inside the atom. It holds the electrons around the nucleus, helping the electromagnetic force in holding the atom together. This gravitational force, it depends on the gravitational law that have been developed by Newton, that generally speaking, if you do have two masses, even if they are non-polar, like carrying zero charges, there is no charge over this mass and there is no charge over the other mass. But if the difference between the two masses is huge, there should be a gravity force that is going to generate between these two big or different masses. And this is the type of force what makes our body sticking to the surface, not sticking, like this is the gravitational force that usually that required on Earth, that require us to live on Earth, right? For example, if we travel to the moon, the gravitational force is very weak, so that's why we fly in the space, right? But here and over the Earth, we can easily move and we kind of sticking to the surface because of the gravitational force. So this gravitational force, it depends on the difference between our mass, which is too small, in comparison to the mass of the Earth, which is too huge. So this type of gravitational force is big enough or suitable enough to keep up us over the surface of the Earth. So this is the same typical force that would exist between the electrons of the tiny mass in comparison to the mass of the nucleus. If you remember, when we discussed the atomic mass, we said that the mass of the electron, it is very negligible, very small in comparison to the mass of the neutrons or the protons, right? So since we have a big difference in the masses between the protons and the nucleus or the nucleus in general and the electron, this big difference generates some forces known as the gravitational force or the gravity force. But this force is the weakest of the four forces. It is very weak force, but it do exist. So these are the four forces that would exist inside that atom, and the function of the gravitational force is to assist or help the electromagnetic force. So it has the same effect as the electromagnetic force in holding the electrons in their orbits and holding the atom together as a single unit. Make sense? So these are the different four forces that would exist inside an atom, and the difference between them and the function of each one of these forces. Make sense? So this is as for the forces inside the atom. How about the forces outside the atom? This is what we are going to discuss. So in the next meeting or the next video, I'm just gonna discuss the forces that would be located outside the atom, which can be grouped as intramolecular forces and intermolecular forces. But as for today's video, we have fixed some keywords. In addition, we just discussed the forces that would be located inside the atom. So that's it for today, and thank you, and see you in the next meeting.